So I hope you're able to see my screen, right? Now listen. So there were 4 more problems that were left out. We did till 8. We'll finish those 4 problems and then we'll go to the next chapter also. So 9th one, how to do? Find the area of the region bounded by the parabola y is equal to x square and y is equal to mod x. So y is equal to x square represents what?
Upper parabola.
It is an upward parabola, that's right. So it is an upward parabola. Y is equal to mod x represents a V-shaped straight line. So what is the area they are asking? This is the area. So how to get this area's value? So when you drop a perpendicular, what is this point and what is this point? So this point will be 1, 1 and this will be minus 1, 1. Right. So how do you solve the problem? Once you take the area as A1, the total area will be 2 times A1, which implies so how to write the equation for A1? A1 is equal to integral of
0 to 1.
0 to 1, yes. See, generally, whenever there are 2 curves, no, there's an important point, make a note of it. Whenever there are 2 curves involved in the graph, area will be equal to integral of A to B, upper curve minus lower curve. Okay. Since you're taking the limits from 0 to 1, this is 1, 0. Between 0 to 1, which is the upper curve?
Y is equal to mod x.
It is only y is equal to x. This y is equal to x, this y is equal to yes. Okay. So upper curve minus what is the lower curve?
X square.
X square dx. If you do this, you will get it as x square by 2 minus x cube by 3 between 0 to 1. It is 1 by 2 minus 1 by 3. It is 1 by 6. So A1 is 1 by 6. A will be 2 times of 1 by 6. That will be 1 by 3 square units. So this will be the required answer. I hope it is clear. So I'm going a little fast. The next one is find the area bounded by the curve x square is equal to 4y and x is equal to 4y minus 2. So x square is equal to 4y is also an upward parabola. X is equal to y 4y minus 2. Now y is equal to x plus 2 divided by 4. Correct? So y is equal to x plus 2 divided by 4. When x is equal to 0, y is equal to half. So it starts here. When y is equal to 0, x is equal to minus half. So it will be somewhere over here. So when you draw, it will be a line like this. Are you guys able to visualize this?
Sir, can you repeat it, sir?
This is y is equal to mx plus c. That is a graph I drew. M is 1 by 4, c is 2. See, whenever you want to draw a line, y is equal to x by 4 plus 2 by 4 means put x is equal to 0, you will get the value of y. Y is 1 by 2. Put y is equal to 0, you will get the value of x. X is equal to minus half. So one of the coordinates is 0, half. The other coordinate coordinate is minus half comma 0. Okay, so this minus half comma 0, and this point will be 0 comma half. So I joined these 2 points, I got a straight line. Yeah,
Sir,
tell me.
Malavik is in the waiting room, it seems. Sir.
Is it clear? So minus
sir.
half comma 0. So 0 comma half minus half comma 0 is another point. This red colored portion will be the area that is required. So solve both the curves and tell me what are the points of intersection. Take y is equal to, take the straight line and substitute it in the equation of the parabola. So we know that x 1 by 4 comma.
1 minute.
Okay, let me check. So x square minus x minus 2 is equal to 0. Correct?
Oh, sir, now y values on this.
I want x values then.
Okay, okay.
X minus 2 into x plus 1 is 0. X is equal to 2 or minus 1.
Yes, sir, yes, sir. Substitute பண்ணுவாரு.
Yeah. So this coordinate will be 2 comma 0. This coordinate will be minus 1 comma 0. But how come minus 1 is here and minus half is here? Okay. Removing this. Now tell me what are the limits to be taken. Integral of minus 1.
To 0.
No, it is minus 1 to 2 directly you can take. No?
Oh, okay. Yes, sir.
It is minus 1 to 2. Upper curve is what? The line. That is x plus 2 divided by 4 minus the lower curve is x square by 4. This whole thing's dx. Calculate the area, that will give you the answer.
Sir, that point is minus 2 comma 0, sir.
Minus 2 comma 0, yes. Just now I observed. It is minus 2 comma 0. Because when we put y is equal to 0, x will be minus 2. That's right. Thank you. Shall I move on to the next one? 3 more problems. With that, we are done. The area of the region bounded by the curve y square is equal to 4x. So area of the region bounded by the curve y square is equal to 4x. What is y square is equal to 4x?
Rightward parabola.
It's the rightward parabola. And x is equal to 3 is a line parallel to x-axis. So this point will be 3 comma 0. This point will be 0 comma 0. So this region and this region is what we need to find, right? So how do you take the limits? Integral of
0 to 3.
0 to
0
3.
to
0
3.
to 3. Yes. Tell me the right curve. 2 root x dx. So this is a1, half of the area. So what will be the total area? 2 times a1. Integral of 0 to 3. 2 root x means take the 2 outside. So 2 into 2 by 3 into x power 3 by 2 between 0 to 3 will give us the total area. 4 by 3 into 3 power 3 is 27. Root of 27 is how much? 3 root 3. So answer will be 4 root 3 square units. If anyone is having textbook nearby, just verify the answer. It is 4 root 3 square units.
Sir, நீங்க இன்னும் into 2 பண்ணனா?
I did know that.
No, sir. We're missing here 2.2 out.
Sir, A1.
Oh, into 2 is there,
4
right? Yeah. Yeah, that's right. Oh, this is A1 only, right? This
Yes.
A1. So which implies total area will be 8 root 3 is right? Huh?
Yes, sir.
Okay. Shall I move to the next one? See. 2 more problems. We are done with it. Area lying in the first quadrant and bounded by the circle x square plus y square is equal to 4. And the lines x is equal to 0 and x is equal to. Tell me in one step. So x is equal to 0 is the center, x is equal to 2 is the end point of the diameter. So the total area of the
Pi by
circle plus
4.
pi r. Yes, pi into it is not by 4.
Pi, sir.
It is pi. Because pi r square is the total area, they are asking the first quadrant. So 1/4 of it will get cancelled. Answer will be pi. So if this question comes in MCQ, you can do it in this way. If it is asked for a subjective part, depending on the marks, you have to do it. So how to do without drawing? Tell me how to do integral of 0 to 2 root of
4 minus x square.
4 minus
that's
x
right.
square.
4 minus x square dx. When you solve this, you will get the answer as 5. Okay, root of a square minus x square. Shall I move on to the next one? 13th. Area of the region bounded by the curve y square is equal to 4x, y axis, and the line y is equal to 3. So y square is equal to 4x is what? It's a rightward parabola. Y is equal to 3 represents
Horizontal.
Line parallel to.
Parallel to x-axis.
yes. So area of the region bounded by the curve, they're asking with y axis. So observe the part I'm going to shade. This is the area they're asking. So when you take the limits of y axis, what will happen?
0 to 3.
Sir, the screen is not visible.
1 minute. Integral of 0 to 3.
Y square by 4.
Y square by
Y
4.
square by 4 divided.
That's right. Y square by 4 dy. Then you will have y cube by 12 between 0 to 3. That will be 27 divided by 12 square units. Is there an option like this?
9 by 4.
29 by 4. 9 by 4. There's the one. Okay. So with this chapter is also over. Miscellaneous. Again, you people have to solve. Any doubts you can approach. Okay. I hope there are no other doubts in this chapter. Right. If
No,
at all
sir.
you want to,
Okay.
if at all you want to do the second exercise also, if at all you want to practice for some other exam, the second exercise is based on this concept only. Area is equal to integral of A to B, upper curve minus lower curve. That's it. Whatever is upper curve, you need to write that first, and lower curve, you need to write it next. Okay, this is the concept for 8.2. If you want, you can try it. Okay. So just give me 2 minutes. I'll start the next chapter. I'll get the textbook and be back. Okay. Listen. So we'll be starting the next chapter, that is differential equations. Okay. So let me explain what it is. You know what is an equation, right? There is a difference between equation and inequality. So what do you mean by equation is what we need to see first. If I give you an expression like this, bx plus c, what will you talk about? What will you say this is?
Polynomial.
It is a polynomial. Right. When can this polynomial become a quadratic equation?
When it is equated to something.
When it is equated to 0. So the general form is like ax square plus bx plus c. If there is an equal to symbol, yes, it becomes an equation, right? Then we call it as quadratic. So here you would have called it as quadratic polynomial. Here we call it as quadratic equation. Okay. Similarly, if I give you sin x, it's a trigonometric function. If I give you sin x is equal to 0, it becomes trigonometric equation. In a similar way, what do you mean by differential equation? So what do
So
we
it
mean
will
by
also be equal to something.
what will be equal
We'll
to
be
0? That is
equating
it.
it to some.
Yes. See, for example, if I have a variable y, then we just call it as variable and leave it. Right? If I differentiate this variable with respect to x, I'll call it as a differential coefficient. If the same differential coefficient is equated to 0, if you use an equal to symbol, then it becomes a differential equation. So this chapter is all about framing a differential equation or solving a differential equation. I'll explain the difference between both as we progress through each exercise. Are you guys clear with what exactly does a differential equation mean?
Yes, sir.
Yes, sir.
Okay. Yes. So this is a very, very simple aspect. So that's what they would have given. We are already familiar with the equations of the type this thing. There's a trigonometric equation. There's a linear equation in two variables. In a similar way, if you consider an equation like this, x into dy by dx plus y is equal to 0, then this equation is called a differential equation. Okay. Now, see, in the differentiation chapter, I would have already introduced this part. I would have told you that dy by dx can be written as y dash, or it can be written as y with a dot on top of it, or it can be written as f dash of x. Right? Do you guys remember this?
Yes, sir.
Yes, sir.
Or this can also be written as derivative of f of x. Okay. So in this chapter, what we do is we use it in the form y dash and y double dash. If you do the second derivative, d square y by dx square, then this will be y double dash. Right? So we shall prefer the use of following notations like dy by dx is equal to y dash, d square y by dx square is y double dash, d cube y by dx cube is equal to y triple dash. So it keeps on going like this. Okay. So for every differential equation, there are two important terms to be kept in your mind. One is called as the order of a differential equation. Okay. So let us take an example. If you have dy by dx is equal to e power x, means the question would have been y is equal to e power x. If you differentiate on both sides, dy by dx is e power x. I hope you are able to understand this, right? So dy by dx is e power x. So I'm able to get a differential equation. Correct? So this differential equation has a parameter called as order associated with it. So what do you mean by order is the number of times the differential equation is, the number of times the function is differentiated. So here the given function is y is equal to e power x. dy by dx is equal to e power x means how many times did we differentiate?
One time.
One time.
One.
We differentiated it one time. If suppose I give you an equation like this, d square y by dx square plus y is equal to 0. If I ask you what is the order of this differential equation, what will you say? Irrespective of whatever you have,
2.
you need to look at all the differential coefficients. Whichever differential coefficient has the highest power, or whichever is the highest order derivative. Order of a differential equation is defined as the order of the highest derivative of the dependent variable with respect to the independent variable. So when you differentiate d square y by dx square means the dependent variable is y and the independent variable is x. I hope it is clear. Okay. So let's take example. This one is what? This is of second order. What about this thing?
Third
3, sir.
order.
So the answer is 3. Is the 3 because of this or this?
Because of
D cube y.
First one, d cube.
It is because of dy by dx. Okay. So here what is happening is order and something, that power is there. No, that power also has another name. You need to be careful. Okay. It is because of the number of times the function is differentiated. We are able to say that the order is 3. For example, if the question had been given like this, d square y by dx square plus dy by dx the whole power 5 plus y is equal to 0. Order.
2.
It is still 2 only.
2.
Okay. Order is 2. That's right. Now the next parameter that is associated with the differential equation is its degree. Okay. So the degree of a differential equation is a 1 minute. I'll show you the reference. See, generally degree of a differential equation is the power to which the highest order derivative is raised to. Okay. So I'm repeating it. Degree of a differential equation is the power of the highest order derivative. For example, if you take this expression, then what is the degree? What is the order first? Tell me.
2.
2.
Order is
3.
2. And what will be the, sorry, order is 3. Degree will be?
1.
The degree is 1. Because you should not look at this 2 and get confused. What should happen? D cube y by dx cube raised to the power 1. The highest order's power is what is going to be the degree. Similarly for this one.
1.
Degree is 2.
Order is 1.
Order is 1. Degree will be
2.
What about this thing?
Order is
Order is
1.
1, degree 1.
Order and degree 1.
Order is 1. Degree?
1.
Okay, there's an important point. Degree is not 1. In this case, degree is not defined. I'll explain why it is so. Okay, we need to read an important point. So, order is defined for all the differential equation. While you're trying to define the degree for a particular question, there are some important checkpoints to be looked after. So, let me read out what is given. We observe that equation 9 is a polynomial equation in y triple dash, y double dash, and y dash. Is it there? So, it's a polynomial equation in y triple dash, y double dash, and y dash. And equation 10 is also a polynomial in what? In terms of y dash, first derivative. So, degree of such differential equations can be defined. So, make a note of it. If you're able to form a differential equation, okay, if you're able to form a differential equation which is polynomial of a differential coefficient, you can define the degree. But what is happening with the 11th one? Let us observe. See. So in the 11th one, it is not a polynomial equation in y dash, and the degree of such differential equation cannot be defined. Why it is not a polynomial of y dash is because, observe the difference I'm going to show. Dy by dx plus sin y is equal to 0. Okay. This is a polynomial. Okay, there is a polynomial equation in terms of what? In terms of y dash. Whereas if you have dy by dx plus, you have any of the functions. It can be any function. It can be sin x, cos x, tan x. That is, it can be a trigonometric function. It can be exponential function. It can be logarithmic function. Any function should have only the dependent or the independent variable inside them. For example, if it is sin y, sin of what does it have inside? Sin of, it has a dependent variable inside. For example, if I give you a question like this, dy by dx plus sin x equal to 0, then can we define the order and degree for it?
Yes.
Degree is going to be how much?
1.
Degree is 1. Whereas if I have dy by dx plus sin of dy by dx, can we define the degree for it?
No, sir.
What is the reason for it? Because sin
Dependent.
is either having a dependent or independent variable. It is having a differential coefficient inside, which is not allowed. Okay, so degree cannot be defined for functions which are not following the polynomial equation condition. So if you do few examples, you will understand. Okay. See, this is a very simple exercise. We can finish it in less than 5 minutes. So let's start with the first one. Wait. Let's start with this thing. Dy by dx minus cos x is equal to 0. They're asking the order and degree. Order.
1.
So how many times?
One.
Order is 1. Degree?
1.
1.
Degree is 1. Second. Order.
2.
2.
That's right. Degree
1.
is 1. Because it's a polynomial equation. Third one. Order.
3.
That's right. Degree. Degree means
One.
power of the highest variable.
Not defined.
1, but it's
Oh.
not defined. Why? Because you
Because,
don't have
E.
because of e power y dash. So what reason you're supposed to write is, since the given equation is not a polynomial equation in what? In y triple dash. So for third one, since the given equation is not what? A polynomial equation in what?
Y triple dash.
In y triple dash, the highest order. In y triple dash, degree cannot be defined. That is the reason. Okay. So here it is not defined. I hope it is clear. So we will do these problems here. So d4y by dx cube plus sin y triple dash.
4.
Order
Four.
4, degree
Not
One.
defined.
1.
Not defined.
not defined because you have sin y triple dash. Second, order
1.
One.
One.
degree
1.
1.
1.
because y dash is the highest order and it is raised to the power 1. So degree is also 1. What about the third one?
Order
Order.
2.
2.
2.
Degree
Order 2.
1.
1.
Yes,
1.
degree is 1. That's right. Fourth one, order
2.
2.
2.
degree
Not
Degree 2.
Not defined.
not defined because dy by dx is there inside cos. Next, order
2.
2.
2.
2.
degree
1.
1.
1 because this highest order raised to the power 1. This one, order
3.
3.
degree
2.
2.
that's right. So y triple dash plus 2y double dash plus y dash. Order 3,
3.
Degree
how much?
1.
1.
1.
1. That's right. This thing, order
1.
1. Degree
Degree.
1.
1.
1.
order
2.
2.
2.
that's right. Degree
1.
1.
1.
that's right. Y double dash, this thing, order
2.
2.
2.
degree
1.
1.
1.
the degree of the differential equation.
Not
3.
defined.
Not defined. Not defined.
Not
Not
defined
defined.
because of sin dy by dx. The order of the differential equation.
2.
2.
2.
That's it. We are done with this exercise. Okay. So the first exercise is about the order and the degree of the differential equation. Okay. Now let's go to the next one. So the second equation is about the general and particular solutions of a differential equation. Okay. So I will directly explain with examples itself. So verify that the function y is equal to e power minus 3x is a solution of the differential equation. What they are asking is, will this function y is equal to e power minus 3x satisfy the differential equation? But see, if I ask you a question like this, find whether 2, 0 is a point satisfying x plus y is equal to 2. Then what will you do? You will substitute 2 in the place of x, 0 in the place of y. Yes, it is getting satisfied. That is how you do the verification. Correct? But here what is going to happen is you have to take this y and substitute it here. The same thing. So since y is given, what we will do is observe. y is equal to e power minus 3x. Then if you observe whatever they're asking us to prove, in that you have dy by dx. So what is dy by dx? Minus 3
minus
e
3
power.
Minus 3
3
e
by
power
3.
3 minus 3.
That's right. D square y by dx square.
9 e power
9
minus
9
3.
e power 3 minus
9 e power minus 3x. So you have to substitute all these things in the given equation. So using all the results in given equation, what do we get? 9 e power minus 3x plus dy by dx is minus 3 e power minus 3x minus 6y. Okay, you should not equate it to 0. You should get 0 for it to get satisfied because they're asking us to verify. So 9. So in the place of y, what should I do?
E power minus
e power
3x.
minus 3.
That's
E
right.
power
E power
minus
minus
3.
3. So this is minus 9 e power minus 3x. This is plus 9 e power minus 3x. So answer will be 0. So y is equal to e power minus 3x is satisfying this equation. Are you guys able to understand? So you would have done some problems like this in the miscellaneous, right? And I gave you an assignment also. In that also there were questions like this. Okay. Shall I move on to the next one?
Yes, sir.
Yes, sir.
So again, observe, verify that the function y is equal to a cos x plus b sin x, where a and b belong to real number, is a solution of the differential equation. So given y is equal to a cos x plus b sin x. Okay. Always take the question as 1. Then what is y dash? Y dash is equal to minus a sin x plus b cos x. Equation number 2. Then what is y double dash? Minus a cos x
a cos x
minus b sin
minus
x.
b 3. Okay. So to find y double dash plus y is equal to, okay, what is y double dash plus y? Minus a cos x minus b sin x plus a cos x plus b sin x will be equal to 0. Hence it is satisfying the equation. Okay. So it is going to satisfy the y double dash plus y is equal to 0 satisfies. Clear?
Yes, sir.
So I'm moving on to the next one. So there are 14 questions. We'll do it fast. So if you look at the textbook, how they would have asked the questions is, they'll ask you to verify. So you know what is an explicit and implicit function, right? If you're able to write anything, any function as y is equal to f of x, means left hand side only y, right hand side is a expression of independent variables, then that is called as explicit. If you're not able to write it in this form, we call it as implicit. So they would have given the function y is equal to e power x plus 1. We need to verify whether this is the solution. That is the whole idea. Okay. So y is equal to e power x plus 1. Verify whether y double dash minus y dash is equal to 0. So always take the question to be equation number 1. Then what is y dash e power x? 2. Y double dash e power x? 3. To find y double dash minus y dash, that is e power x minus e power x, answer will be 0. Okay, this is one way, or the alternate way is subtracting the third equation from the second equation from the third equation. That would be y double dash minus y dash. That is also equal to 0. Are you able to understand?
Yes, sir.
So this exercise is about your differentiation only. You can ask me why is this chapter after integration? It is because from the next exercise you will need it. As of now, what you're doing is you're forming the differential equation. In the next exercise, what will happen is they'll give you the differential equation. They'll ask you from which function did we get this differential equation. Okay, moving to the next one. Y is equal to x square x plus c. See, this kind of an equation is called as a general solution. Try to understand one thing. This is function. This is the differential equation. So when you differentiate a function, what do you get?
Differential equation.
Differential equation. So what will be the reverse process of differentiation?
Integrate.
Integration.
If differential equation is given to you, if you integrate the differential equation, you should get back the function. That is the meaning. Okay. So when any function is given to you and you get a differential equation, when you integrate the differential equation, you're getting back the function. No. So functions are basically classified into two types. So it's not function, I'm sorry. Function, which is actually the solution of differential equation. Why we call it a solution of differential equation? Because to a given differential equation, when you integrate it, you're getting back the function. That is called as the solution. So the solution of differential equation are classified into two types. One is called as general solution and the second is called as particular solution. So general solution, a general constant is used. Particular solution, fixed value is used. The meaning of that is, if I give you a function y is equal to x plus 3, I'm saying it is a solution of a differential equation and I'm asking you a question. Is this a particular solution or a general solution? What will you say?
Particular.
It is a particular solution because if you observe, 3 is a fixed number. Whereas if I give the same question as y is equal to x plus c, then it will become a general solution. So in this question, they have given you the general solution of this differential equation. Okay. So what we need to do here is just differentiate the given function and see whether the right hand side is satisfying or not. So y is equal to x square plus 2x plus c. So y is equal to x square plus 2x plus c. What is the highest order we need? Y dash. So differentiate it once. Y dash is equal to okay.
2x.
First
Sir, 2x, sir.
2x, right? Sorry. Okay. So if you look at the second equation, if you bring 2x and 2 to the left hand side, then y dash minus 2x minus 2 will be equal to 0. Hence, the given function satisfies whom? Satisfies the differential equation. Got it? Now see. Third one. Y is equal to cos x. So equation number 1. Y dash will be minus sin x. So take this minus sin x to the other side. Y dash plus sin x will be equal to 0. This thing. It satisfies. So every question will satisfy only. Your work is only to prove. Okay. Moving on to the next one. Now tell me how to solve this. So y is equal to root of 1 plus x square. Is it a general solution or a particular solution?
Particular solution.
Particular solution.
A particular solution. So highest power needed here is y dash. So y dash will be equal to 1 divided by, so derivative of root x is 1 by 2 root x, 1 plus x square, into derivative of 1 plus x square is 2x, 2 and 2 will get cancelled. It will be x divided by root of 1 plus x square. X divided by root of 1 plus x square. But here you have something else. Right. So I will take this as equation number 2. Now what I will do is to find y dash minus xy by 1 plus x square is equal to what? What is that we are supposed to get? Y dash minus
0.
xy divided. You're supposed to. I'll tell you two methods to solve. Okay. Y dash minus 1 by xy divided by 1 plus x square is equal to what? So y dash is x divided by root of 1 plus x square minus x into what is y? Y is root of 1 plus x square divided by 1 plus x square. So it will be x divided by root of 1 plus x square minus x divided by root of 1 plus x square. This will be 0. Are you able to understand? So it is still satisfying. Is it clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I told you there is an alternate way, right? Observe. The other way to solve this is, if at all you don't want to do this manipulation, you have y dash in your hand. Okay. You got y dash as x divided by root of 1 plus x square. But if you look at the question, they have given y dash is equal to xy by root of 1 plus x square. Right. So what we can do is y dash is equal to, can I write it as root of 1 plus x square into 1 from here? Can I write it as x divided by root of 1 plus x square into 1? Now observe, what is y divided by root of 1 plus x square?
1.
Here, y divided by root of 1 plus is y. 1. So with respect to the context of this question, we can write it as x divided by root of 1 plus x square into, what can I write? Y divided by root of 1 plus x square. So what is that you will have? Xy divided by 1 plus x square. There is another way to prove. But again, I'm repeating, whichever is convenient for you, you can take it. Both are right.
So can you repeat that alternate method, sir?
See, I wrote x by root of 1 plus x square into 1. Okay. From the question,
Sure.
I wrote what is 1 by root of 1 plus x square. That is also 1. So in the
Okay, sir.
place of
Okay, sir.
1, I replaced with y by root of 1 plus x square. You can ask me how I got that idea. The idea actually came because the question has root of 1 plus x square. But when can I eliminate that root of 1 plus x square? Only when I multiply with other root of 1 plus x square. So that is why I wrote it in that way.
Okay, sir.
Yeah. So I'm moving on to the next question. Y is equal to ax, xy dash is equal to y. Okay. Y dash is equal, so y is equal to ax, 1. Y dash is equal to a, that is 2. Okay. To find x into y dash minus y, or I'll say x into y dash. I'll take only the LHS. X is how much? X is x only. Y dash is a. So that's nothing but ax. But what is ax?
Sir, your video got stuck, sir.
Issue. Till where was I audible?
Fifth question.
Okay, fifth is over, right? Now see, the sixth one is y is equal to x sin x. Xy dash is equal to y plus x into root of x square minus y square. Okay. So when you take y is equal to x sin x, let that be equation number 1. Y dash will be x cos x plus sin x when you will differentiate it. So what I did is I took the RHS. So for RHS, when we find y plus x into root of x square minus y square, it came out as x into sin x plus x square cos x. Okay. Let this be equation number 3. That is RHS. Now taking the LHS, what do you get? X into y dash. That is x into y dash is x cos x plus sin x. What will you get? That will be x sin x plus x square cos x. That will be 4. So LHS will be equal to RHS. Got it? Yes or no?
Yes, sir.
So I'm going to the next one. 7th. Xy is equal to log y plus c. Xy is equal to log y plus c. Then we need to prove that y dash is equal to y square divided by 1 minus xy. So let this be equation number 1. Differentiating 1 on both sides, what do we get? X into y dash plus y is equal to 1 by y into y dash plus 0. So x into y dash plus y is equal to 1 by y into y dash plus 0. So which implies y dash into x minus 1 by y is equal to y, right? So I'm just rearranging the differentiated part. So y dash into xy minus 1 divided by y is equal to y square. Sorry, y. Is that what they have asked us to prove? Y dash is
Sir,
1
it should be
minus.
minus, sir.
Yeah. It is.
Minus y.
It is actually, yeah, I made a mistake. 1 by y minus x, no? it will be 1 minus xy divided by y. So y square divided by 1 minus xy. Now I hope it is clear. So what I did is I differentiated the equation. I just tried to rearrange. I got the answer. Okay. Yes or no?
Yes, sir.
So y minus cos y is equal to x. So let this be equation number 1. Differentiating 1 on both sides, you will get y dash minus of minus sine y into y dash is equal to 1. Y dash into 1 plus sine y is equal to 1. Is that clear? Let us take this as equation number 2. So consider the LHS, that is y sine y plus cos y plus x into y dash. Okay. So what should we get? We should get a y. So how to solve this? Tell me. So in the place of y, what can we substitute?
X plus cos y.
X plus cos y.
That's right. X plus cos y into sine y plus cos y plus x into, what is y dash?
1 by 1
Whole
plus
divided by 1 plus sine y. But is it not getting complicated? Because x sine y, there is nothing that is getting cancelled. So let us not do this.
Sir,
Yeah, tell me.
x plus cos y is nothing but y, sir, from the LHS.
Yeah, that's right. So x plus cos y is nothing but y. So y sine y, that's it. It's getting cancelled easily, no? Yeah. So from 1 minute. Y sine y plus cos y plus x into y dash. Okay. We know that cos y plus x is nothing but y. So y sine y plus, in the place of y, what can we, y sine y, if we take out y common, what will you get? If
1
y
plus
is
sine
taken,
y.
1 plus sine y into what is y dash?
Y dash.
Y dash is also 1 plus sine y. So this and this will get cancelled. You're left out with what? Y, which is nothing but the RHS. I hope it is clear.
Yes, sir.
Yeah. Okay. Moving on to the next problem. X plus y is equal to tan inverse y. Prove that y square into y dash plus y square plus 1 is equal to 0. Okay. So differentiating 1 on both sides, what do you get? X plus y dash is equal to 1 by 1 plus x square into y dash. So if you take
So
out
1 plus
y
y
dash,
square.
1 plus y dash.
sorry.
1 plus y dash.
1 by y square.
Yeah, sorry. 1 plus y dash is equal to 1 by 1 plus y square into y dash. So I'm taking y dash to the other side. You will have 1 plus y square minus 1 is equal to 1. Correct? So y dash into, if you take LCM, you will have it as y square divided by 1 plus y square is equal to 1. So y dash into y square is equal to 1 plus y square. Is there a minus somewhere? Am I missing a minus?
Minus y square, sir.
Minus y square, sir.
Yeah. So which implies y dash y square plus y square plus 1 is equal to 0. So this is a required answer. So it is satisfying, right? So I'm moving on to the next one. So you people do this, no? Y is equal to root of a square minus x square. Let this be equation number 1. You need dy by dx. So y dash is equal to 1 by 2 root of a square minus x square into minus 2x using the chain rule. So using 1 into what do we get? Y dash will be equal to 2 and 2 will get cancelled minus x divided by y.
Y.
So which implies y dash plus x is equal to 0. That's the required answer, no? X plus y into y dash is equal to 0. That's what we need to prove. Okay. Moving on to the next one. See, suppose I have a question like this. Y is equal to ax. Okay. So then I can ask you a question stating that form a differential equation. So when I say a differential equation, dy by dx will equal to a. Is it right? Which implies a is equal to y by x. No, substitute it here. Dy by dx. So this is the required differential equation. Okay. Now the question is, how many arbitrary constants did I have? How many variables did I have? I mean the constant
One.
things which I have.
One.
1.
So number of arbitrary constants will be equal to the order of the differential equation. Means see, if you observe the question that is given, it has a, whereas when the differential equation is formed, the a is eliminated. Okay, so the order of the differential equation will be equal to the number of arbitrary constants. So tell me what will be the answer?
4.
The number of, that's it.
Sir, I didn't understand.
You have the number of arbitrary constants in the question is equal to the order. That is what I'm trying to say. So for example, you have y is equal to ax plus b. How many constants do you have? Arbitrary constants, right? So if you do dy by dx, what will you have? You will have a, right? Then what is d square y by dx square? That will be 0. So when you frame a differential equation, you need to eliminate the arbitrary constants that are there in the given function.
Okay,
So how many
sir.
were there here? 2. So how many times did I differentiate? 2. Beyond this, if I do, I'll get d3y by dx square is 0. But those are all not taken into consideration. This will be the final differential equation.
Yes,
Okay.
sir.
Next, the number of arbitrary constants in the particular solution of a differential equation of third order.
0.
The number of arbitrary yes, it is 0. Okay, so do that. That's it. This exercise is over. Okay, so I'll give you an outline of what will be the next exercise. The third exercise is forming the differential equation. So it is about, you need to form a differential equation, but if I'm not wrong, this is also deleted from your portion. But I'll explain few problems for you to understand, okay? Next class I'll do that. I'll explain few problems based on this, though it is deleted. So till 9.3, what we are going to do is, the function will be given, we are forming the differential equation. From 9.4 onwards, they'll give you the differential equation. They'll say, what is a function on differentiating? You will get this kind of an expression. Means we need to do integration. So from here onwards, we need integration. That is why this chapter is given after all the integrals. So you have 2 more exercises. We have completed 9.1 and 9.2. 9.3 is deleted. 9.4 and 9.5 is there. 9.6 is also deleted. Okay, so 2 more exercises. Maximum we can complete it in 2 more classes. Any other doubts from today's class?
No, sir.
No, sir.
No,
Yeah.
sir.
So no doubts means we can wind up. Okay, can log off.
Thank you,
Thank
sir.
you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.